Welcome to this presentation on Micronaut and GraalVM, the most productive framework for building cloud-native applications. For those of you who have not heard of GraalVM and who hasn't, it is a new virtual machine out of Oracle Labs that is able to, in JIT mode, increase your application throughput between 20 and 30%, and is also able, using a closed-wall static analysis, to produce native binaries that are great for cloud deployments, dramatically reducing memory consumption and startup time. In addition to that, it includes the Truffle language framework, which allows you to seamlessly interoperate different language runtimes, including JavaScript, Python, and so forth, in a single virtual machine. If you want to find out more information, you can click on the links at the bottom of the slide and access information about GraalVM. In this presentation, we're going to focus specifically about Micronaut and the native image tool. Native image is one of the most compelling areas of GraalVM, and what it does is it performs a closed world static analysis of a regular Java application by running it within Hotspot, traversing the code and finding all reachable parts of the code, and creating a snapshot on image of the initialized heap and compiling the code into a native executable, much like C++ does. What this allows and what this enables is applications that have a much smaller footprint and can start up significantly orders of magnitude faster and reduce the amount of memory needed to actually run the application. The technique of using closed-world static analysis basically requires that you feed into native image all the information about anything dynamic that your Java application may or may not be doing. For example, any reflection, any dynamic class loading, etc., in order to enable a accurate closed-world assumption. And this is where Micronaut comes in. Micronaut is a modern JVM-based full-stack framework for building modular, easily testable microservice applications. And it plugs into your Java compiler through the use of annotation processing and effectively computes the way the framework needs to work at compilation time, rather than waiting until runtime and using traditional techniques like reflection and dynamic proxies and so forth. It does all of that analysis during compilation. You can find out more about Micronaut at the links below, including documentation and being able to create your project with Micronaut Launch. Micronaut's architecture and build time architecture has significant benefits, including the elimination of reflection and runtime proxies. And this provides a number of different aspects to the application. One of them is reduced memory footprint. The lack of reflection means that Micronaut applications typically require a lot less memory to run. Smaller stack traces as well, because just dispatching to your actual code, to the application's code, doesn't involve the use of reflection. That dramatically reduces the size of the stack traces that Micronaut generates, as stack traces are much smaller, which also results in better throughput and performance. The lack of reflection also has a great impact on improving the security of your application. Arbitrary serialization via reflection has been traditionally one of the biggest security holes in the applications. Micronaut only allows essentially the compilation time computed classes to be serialized and deserialized, which improves security greatly, as well as the robust compilation time checking adds a lot of value in terms of catching developer errors early on and not leaving them and letting them become runtime exceptions or problems that can result in bugs in the code. It also means that Micronaut is effectively static analysis ready, which is what I alluded to in the previous slide, because there's no reflection, no runtime proxies, no dynamic class loading in Micronaut. It's already ready to be statically analyzed by static analysis tools. And one of these static analysis tools is, of course, GraalVM native image. And Micronaut is by default compatible with native image out of the box. It's not added on as an afterthought, and there's no need to generate additional configuration to feed into the native image tool. The code Micronaut generates is automatically already ready to be run within native image. So Micronaut has a great relationship with GraalVM. In fact, Micronaut loves GraalVM, and GraalVM loves Micronaut because there's a lot less to configure when you pass a Micronaut application to native image, there's relatively little configuration needs to be passed in. They're just the elimination of reflection, runtime proxies, etc., and runtime bytecode generation means like there's a lot less work that the tool has to undertake. And the net result is remarkable. You can have an application that starts up in 20 milliseconds, dramatically reduces memory consumption to 18 megabyte, and allows you to take Micronaut applications, to places that were not even possible before. So this is great for many use cases, including things like serverless, scaling to zero, which really helps with the cold starts, IoT, where you want to deploy to an environment which has dramatically less memory available to you. Micronaut plus GraalVM native image allows you to, for example, run a Raspberry Pi. And lots of different use cases, scaling by processes in terms of running many different microservices within Docker containers, for example. It has a great impact on those types of applications. It even has an impact on, for example, testing, as if you use things like test containers to spin up containers that are built into native image, these spin up way quicker than the equivalent JIT versions and help when it comes to the moment of testing your application. Micronaut also has a really strong focus on productivity and compilation time checking, as I mentioned. So Micronaut will actively, through hooking into the JavaC compiler, check that your application is correct. Traditional frameworks like Spring and JAX-RS and so forth use annotations that have many kind of stringly typed things. For example, you might define a URI variable that's contained within a annotation that maps to a particular request route. And in this case, those URI variables have to match parameters that you pass in the method. And Micronaut will actively check that those parameters are correct, failing compilation if they are. And, in other use cases as well, like, for example, data repositories, if you try and query a property on a persistent entity that doesn't exist, that results in a compilation time error, rather than you running your application and failing at runtime with a mysterious error, or, for example, even worse, you miss some test coverage and you go into production and you have an error at runtime because some property doesn't exist or some route is incorrect through lack of testing and so forth. So, and in addition to that, Micronaut is very focused on productivity in reducing the amount of code you have to write. In this example, for example, we have a function written in Micronaut, which allows the developer to focus on the business problem, which is, writing the actual function rather than the surrounding infrastructure. The code on the right is essentially how you would handcraft a function without Micronaut. And there's a lot of code which is essentially plumbing in terms of getting the function going, that just disappears when you use Micronaut. So you can actually just focus on your business logic, which is what developers want. They want focused environments where they just focus on the code that they care about, which is writing the function, rather than focusing on all the initialization part. And Micronaut provides many utilities around different areas, for writing serverless functions to writing applications that provide that plumbing code out of the box. And in addition to that, Micronaut has great support for relational databases and database access in general, and it's all compilation time checked. So you can define repository interfaces, and they can be backed on either JDBC or JPA. You just define your interface and it'll automatically, at compilation time, generate the appropriate query that needs to be executed. And if you somehow made a typo in the interface that you're defining, Micronaut will check that at compilation time and fail compilation if it's not possible to implement that query, rather than waiting to runtime like a traditional framework and providing the error at that point. All of this provides a dramatic reduction in boilerplate code. The code on the right here is how you would, for example, handcraft a SQL query that you want to write and bind to a bunch of POJOs. With Micronaut Data, it's just an interface, and all of that logic is automatically implemented for you, ensuring that you the correct transaction semantics are applied, ensuring that connections are closed. It's often a source of bugs that developers, forget to close connections or forget to close a particular prepared statement or a prepared result set. All of that is handled automatically for you by Micronaut, which produces much more robust and tried and trusted code that the developer doesn't have to worry about. So massive productivity for database access as well. And then as we move to the cloud, Micronaut features fantastic integration with Oracle Cloud in a number of different areas. So for example, if you're building serverless applications, Micronaut provides support for writing Oracle functions that are both regular low-level functions that respond to, for example, cloud events, to HTTP functions that run behind an API gateway. In addition, it provides direct integration and support for natively using the Oracle Cloud SDK. So that's things like object storage and so forth. As well as that, it also provides slick integration with the Oracle Autonomous Database so that it will automatically set up the wallet requirement that you need in memory and connect to Autonomous Database when you're running in the cloud, providing all the plumbing needed to do that, rather than you having to supply the wallet. There's also great integration with things like Oracle Cloud Monitoring to supply metrics to Oracle Cloud Monitoring from the Micronaut application on a number of aspects of how your application is functioning, such as request counts, memory, etc. All that gets fed into the metrics, Oracle Cloud Monitoring metrics. And in addition to that, we have support for Oracle application performance monitoring, which basically allows you to view distributed trace information as your microservice architecture is invoked and service to service calls. So you can follow a distributed trace from exactly where it began, right down to when it accesses the database. And in addition to that, we have fantastic support for things like Oracle Cloud Vault. If you want to store, for example, secrets in your application, Micronaut has the ability to automatically look up those secrets and turn those into cloud-native configuration, which automatically configures your app based on the presence of those secrets. All of that is available in the Oracle Cloud module for Micronaut, which you can find out more information about in that link below. And Micronaut really has a great relationship and a great integration with Oracle Cloud, which developers are going to love. In addition to that, with Micronaut, we have been building great support for Visual Studio Code. You can go to the marketplace and install the Micronaut and GraalVM plugins, and they provide fantastic features to run Micronaut applications, create Micronaut applications, build native images, run your tests, test visualization, and really great productivity features for the VS Code environment. You can push Docker images as well directly to container registry, and really a fantastic developer experience to augment the existing commercial options available out there, which is really great. So in summary, Micronaut, GraalVM, and Oracle Cloud provide a robust modern architecture for building cloud-native applications, prioritizing security and correctness through build time approaches, the compilation time checking, the elimination of reflection, creating more optimized applications with greater throughput. And and also through the use of sensible defaults. Developers want to focus on their business problem, not how to get their application running in the cloud. And Micronaut provides all those features in order to get started building your cloud native applications today. And you can start today by going to micronaut.io/launch, creating your application and getting started out of the box. So thanks very much for listening to this presentation. I hope that provide a summary of what Micronaut is and what GraalVM is. In the following videos, you'll find out exactly how to build Micronaut applications and get to actually see and learn how Micronaut, GraalVM, and Oracle Cloud work together.